Hey everybody, Lars here. Time for the third and final video for Unit 5. This is a fun one. We're going to get going right away and we're going to start building on some of the things that we did in video 2, but you're going to see we're going to go quick. We're going to talk about a bunch of different facets of classes and object-oriented programming. None of them so big they need their own video, but we're going to do a couple of different things to take our animal class and make it cool. As I always say, we're going to go quickly, but we're not going to go that quickly because I want you to get something out of it. The first thing we're going to do lickety-split is we're going to take our old code here and we're going to quick run it and trace through it so that we are familiar with what we're doing again. So we'll go to the beginning of the code up here. Comments get ignored. Class animal, this gets put in memory. Class cat, which inherited from animal, if you remember, gets put in memory. Comment, literally the first thing we have here is the second to the last command where we have a variable called cat1. We assign it a cat object created with the cat class. And when we run the constructor, we have the string Felix, the integer 50, and the string black. So we come up here. Self, you understand self is something that points at the actual object when we create it. Name is Felix, weight is 50, color is black. Okay, so we, because we're inheriting from animal, want to run the constructor of our superclass. We do that with name and weight. So with Felix and 50, we come up to animal and we run the constructor. And all this constructor really does is set the instance variables. So Felix will go there, 50 will go there, returns to where the call was, which was right here. And then here in cat, because it's only for cat, we take the color and give it an instance variable. And then we're done, okay? So then what we do is we print cat.getColor and cat.getName. So for getColor, cat1 is what? It's a variable that holds an object that was created with the cat class. We go to the cat class and we say, is there a method called getColor? There is. What does it do? It returns the color, in this case black. So you can see up here the first thing we print is black. All right. Then cat1 is a variable. It holds an object created with the cat class. We go to the cat class. Is there a method called getName? There is not. Python's about to throw an error. Except we go here. And Python says, did cat inherit from anything? And we say, yes, it inherited from animal. So we go up to animal. Is there a getName here? Yes, there is. So we return self.name. In this case, it is Felix. It was set at the very beginning. And that's what we print right there because of that print statement. Okay? So, ran through it pretty quick, but I'm guessing you probably went back and watched video 2, or you're watching them together. So, this is probably right after that video. Watch me work. I'm going to take this cat class. I'm going to say copy. I'm going to paste. I'm going to come here. Hey. I'm going to call that dog. I'm going to go to speak. Woof. Just that fast, I now have a dog class. Look at that. Okay? Same as the cat, inherited from animal, just adds a color, but when I make it speak, it says wolf. We may play around with that later. I'm thinking I was going to do something different. So, what am I going to do? I'm going to copy these 2 lines. And I'm going to come down here. And I'm going to paste, I'm going to come down here, and I'm going to paste. And what I'm going to do is I am going to say cat2, and I will make another cat, and I'll call this cat Rex, and Rex will be lighter. We'll make Rex 30 pounds, and Rex will be a orange cat. I had an orange cat when I was a kid, so that kind of works. All right, now we're going to have a dog. Let's say dog. And dog is going to be created with the dog object, not with the cat object. And dog's name is going to be, we'll call Fido. And Fido will be, I'll make Fido 45 pounds, let's say. And Fido will be, we'll make Fido red. Fido can be a Irish setter. So there we go. So now we get red. So here we want to say cat2. A cat2, and here we want to say a dog1, and here we want to say a dog1. So now, that quickly, I'm going to save, I'm going to rerun. I have 3 animals now, black Felix, orange Rex, and red Fido. Okay? I don't know if my OCD is going to allow me to leave those colors in lowercase. I'm guessing not. The magic. My fingers just start working without me allowing them. So now looks a little better. Red Felix, orange Rex, red Fido. So now my little zoo is growing. I have 3 animals, or 3 different objects. I'll do it later. I was going to set something up. So I have 2 cats and 1 dog. Created 2 with the cat class, 1 with the dog class. They both inherit from animal. Okay. What if and we're going to see this little idea here is going to take care of, it's going to kill 2 birds with 1 stone. What if I want to keep track of how many animals I have? Let's say this is a big, wide program, and sometimes you create an animal, sometimes you don't. I want to keep track of how many animals I have, okay? So you're probably saying to yourself, because you're an old Python dog at this point, you're saying to yourself, that's easy, Lars. What I'm going to do is I'm going to create a counter. And every time I create an animal, I'm going to click that counter. Well, I tell you, you're right. That is a good way to do it. It's a perfectly proper way to do it. But when we use object orientation, there's kind of a clever, interesting way that we can do this using classes. Now, when we create classes, we create our instance variables. So when I create an object, this cat 2 has Rex and 30 and orange, and dog 1 has Fido and red and blah, blah, blah. They all have their individual variables, or their instance variables, because there's an instance of the class. It's an actual object. What if I wanted to have a variable that all of the objects could share, and the fact that they were all coming from the same class let them see that variable? Okay? We can do that. Whereas when you create your object, you have instance variables. You can also have something called a class variable. The dirty little secret is that the first time you instantiate something with a class, there's 2 objects that get created. One is your instance variable. One is the object that you're using. And another is a wide, big kind of central place for the class. So when you create cat, you're really also creating a big overarching cat class object. And that in turn is creating a big overarching animal class object, okay? You can have variables there that all of the objects can see, and we're going to do that. So I'm going to show you how easy it is. You see here class animal. I'm going to do it in animal because dog and cat both use it, and I want to know when I have an animal, not when I really have a dog or a cat. All you have to do is come down here, and outside of the class, not in any of the methods, this is the first time we're going to do something outside of the methods, all you have to do is create a variable name. And I always initialize it. And that's it. So now we have a variable called animal count. But here's the trick. I want animal count to keep track of how many animals I have, right? So what happens when I create an animal? What's going on? The constructor gets run, right? So maybe in the constructor, that's the place I want to click that counter. So I'm going to say a count plus equals 1. Now, I can tell you right now, if I run this right now, it's going to explode. Well, you know what? Let's do it. Boom. Okay? Because I'm inside of the constructor and I'm accessing a variable, and even though I'm there inside the class, it's saying, whoa, what variable am I looking at? What is this right here? The reason we use self is because when we're creating the class, we don't know the name of the object. We don't know the memory location or where that thing is. But as far as a count is concerned, we do know where it is. It's in the animal class. It's a class variable. So what I need to do is tell Python that, hey, this is a class variable. I want you to go to, yes, idle, look at you. I want you to go to animal.acount and increment it by 1. So now when I run things, I'm back in business and things are running again, okay? But I can't access it. I can because it's public, and if I printed it out, it would work. So what I'm also going to do is I'm not going to get a setter because we set it using our constructor. But I will create a getter. I'll call it get a count self, and it returns animal dot a count. And that's it. So now if I want, I can come down here, and after, I guess I'll do it right here. I can say cat1 dot get a count. Okay? And then let me highlight that. Copy. Paste. Paste. Now I could leave that cat1 there, because you can access it with any object on it you want. But I'm going to make things normal here with our cats and our dogs and our this and our that. So now when I run it, 1, 2, 3. It keeps track of how many animals I have. Okay? So now we got that problem licked. I added a class variable, and in my counter I increment it. So when I create an object with animal, then I'm going to click that counter, and I'm always going to know how many I have. You can see I printed them out down here. So when I run it, you can see 1, 2, and 3. Okay? So we got that problem licked. We know a little bit about class variables, but now, what's the natural question that comes up after what we just did? The pregnant pause for you to answer it yourself. Imagine. You're probably thinking to yourself, okay, we've created 3 objects. How do we get rid of an object? It's a shame because they're animals. How do we destroy an animal? How do we get rid of an animal? It's rather simple, frankly, because there is a keyword that does it. What am I doing? I'm getting rid of the second cat. We'll get rid of the second cat. DEL, as you could probably guess, it stands for delete, is the way we get rid of an object. So if I type DEL cat2, we would get rid of it. So now I run, and I don't see anything, right? But if I came down here and I said print cat2 dot get name, and we ran that code, it blows up because cat2 is not defined anymore. I deleted it. I got rid of it. So what I really want to do there is I want to let the world know that I deleted that cat somehow. So, as you may imagine or may not imagine, I don't know that it's crazy intuitive, when you create an object, you have a constructor, and that constructor's name is init for initialize. Well, when you destroy an object, you can also create a method for it, and it's called the deconstructor. And the deconstructor, you ready? Is dunder del dunder. So now when you delete an object, we can tell Python what to do when we delete it. So what I'm going to do is I'm going to say print an animal has been destroyed. I'm going to say colon space comma, and then I'll say self.name because it's not destroyed yet. So I can still print out the self.name variable, and we'll see what animal goes. And then I'm going to say animal minus equals 1. Okay? Animal, just animal, dot a count. So I'm going to take my animal counter, and I am going to decrement it by 1. So now I had 3 animals. I'm going to delete 1. So boom, I'm going to print that message, and I'm going to take my counter back down to 2. And the way we're going to see that is we're going to print that line, and then I want to print, and I'll just show you. We'll just go right to it because it's public. Print animal a count, and it should print 2. Okay? Actually, we'll do this to make it more understandable. We'll say animals left colon comma animal dot a count. So when we run this code, we see black Felix 1, orange Rex, red Fido 3. But now we see an animal has been destroyed. We've destroyed Rex. Indeed, Rex is the second cat. And now animals left 2, because that's where our variable sits. Okay? So what happens here is we've now learned how to delete an object. And when we delete an object, we can set up our deconstructor. Now you'll notice I put the constructor first in the method list, and I always put the deconstructor last. That's kind of a, you don't have to, but it's kind of a programmer convention. I mean, people have been doing that ever since I learned how to do classes, like in the 80s. You always have your constructor first and your deconstructor last. If you know anything about the programming language C++, the constructor is actually the name of the class, and the deconstructor is a tilde and then the name of the class. So the tilde would be the opposite, or the deconstruction of the object. Okay? So you can now tell what you have a method that runs when you create your object, and now we have a method that runs when we get rid of our object, and we get rid of it, okay? So now, frankly, we have that whole keep track of the animals problem licked, right? Because 1, 2, 3, now we get rid of 1, it's back down to 2. If we created another, it would add it. We're in pretty good shape. So I like that. Now we're going to harken back to something that we've been discussing all along with self and these objects and where they are. It is real easy for me to print just, let's say, the value 10. Okay? Print the integer 10. Let's see what it does. Prints 10. Perfect. Let's say I have a equals 10. Now I can use a variable, and I can print 10 again, because I print the variable and it gives me the value that is stored in the variable. Okay? Do the same with a string. Do the same with a float. Here's the question. What happens when I print cat1? And you know, because we talked about it at the end of the first video and a little bit in the second video. When I print cat1, I get this funny little thing right here. Main cat object, blah, 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 blah. And what that is the memory location of the object. Because it's really all Python has. It says, I've got a variable named cat1. And this is where the object begins. Boom, right there. Okay? But we could do something different if we want. We can override the method that tells print what to do. See, the dirty secret here is that when you create your class, you get that superclass object. All of your methods, including init, including del, including a whole bunch of dunder methods that we're not even talking about because I don't want to confuse the hell out of you, get inherited from a big, almost default superclass. Okay? That big default superclass has a method that tells print what to do, and that's what's telling it to print the memory location. We can, like we did with speak, override that method and tell Python what to do when we run a print on our object. And that method is, and I'm going to come here and I'm going to create one after speak but before del. That method is dunder, str dunder, or string. Okay? And you run it and it says self, but, and this is the thing, you've got to know how string works. String returns a string. It returns what gets printed. So what we're going to do is we're going to create that string. We're going to have a variable called a string, and I'm going to say animal obj for animal object. Let me put a colon there. And then I'm going to concatenate because I'm dealing with strings. And I'm going to say self.name. And then I'm going to say plus. And then I'm going to cast because I got to make sure I'm giving it a string. And I'm going to say self.weight. Okay. Now, these are the only variables that I have in animal. I'm not going to deal with the color. Because if I wanted to, I could go and do this in dog. And I could do this in cat. And everything would be fine. But right now, I'm in animal. So I'm going to leave it at animal. And then, you know, we could trace through it later, but you know the deal. It's going to look for it in cat. It's not going to find it. It's going to come to animal and says, hey, has the dunder string dunder been overwritten? And it turns out it has, so it'll use that. So then basically all you have to do is return the string that we've created. So we return a string, and that's what's going to get printed out now when we print cat. Okay? Let me get rid of that. So when we print cat, what's going to happen? Cat1, created with the cat object. I'm going to come up here to cat. It's going to say, because it's doing a print, it's going to say, hey, is dunder, string dunder overwritten? No, but I inherited, so it's going to come to animal. And it's going to say, hey, is there a dunder, string dunder? And it turns out there is. So we're going to create this string, and then we're going to return it. And we're going to print all that information about cat1, which is Felix. Okay? Watch me work. So here we go. Animal object, Felix 50. All right? So you can now tell Python what to print when you print your object, because all you have to do is override the string method. Now what I did here is an old story in itself. Back in the day, objects, when they were new, you got into like pickling, you got into serialization, where you would take a complex data item and put it straight in serial. You would give it a straight line so that you could store it in a sequential file. Well, people used to go back and forth on what was truly a serialized object. Is it just the data of the object, or is it the data with all the methods you can run on it? And is it the whole class deconstructed and put there so you can construct the class as well as the data and things like that? What a lot of people, myself included, used to do when we printed out objects is we would just do what we used to call a state dump. And all a state dump is where all of the variables are, what the values of all of the variables that particular object has is. So in our case, we have direct access with animal to name and weight. So I just did what we would call a state dump. I just told you what the name was, and told you what the weight was at the time you asked for it. Okay? And that just it tells you what the state of that particular object is, because it gives you the value of all the different variables. A lot of times, that's what a programmer is going to do. If you ask it what an object is all about, you're just going to get a state dump. You're literally going to get the value of all the different variables to tell you where that thing is at that particular time. Excuse me. I must need more coffee. I must be low. Okay, so that's what that's all about. Putting the string there, as you know, you've probably heard me say it before, Python doesn't support what we call overloading, or giving things a bunch of different meanings, but we can override. So that overrides the big dunder string dunder that would give you the memory location, and we say, hey, build our little string, and then print that little string out. And that, for our purposes, is more informative and better for us when we use the print. Okay? So, boom, boom, boom. Basically, the different things I wanted to show you in this particular video were class variables, which we did with acount, deconstructors, the fact that you can create a method that also has a list of instructions for when you get rid of the object, and not just a constructor for what you do when you create it. And also I wanted to show you overriding functions and overriding dunders like string to give your object more functionality. Later, when you become a more sophisticated Python programmer and you start looking everything up for yourselves, you're going to see there's tons of dunders that you can go and rewrite and do to customize your class so that it works the way you want it to work. Okay? We're going to do two more things, actually. I used to do just one more thing in this video, but I think we're going to do more than that. What I'm going to do here is I'm going to say File, I'm going to say Save As, and I am going to save this file as analib.py. So analib right there. So it's called analib.py, and then I'm going to come down here to the main part, and I'm going to copy it. Oh, I hope that worked, because I'm going to delete that. Okay. Now I'm just going to save this as analib and leave it there. And then what I'm going to do is I'm going to grab a new file. And I'm going to do my goofy little comments as I am wont to do. I'll call this animal main prog. And I'm going to come down here. I'm going to paste my code back in there. Okay? And I'm going to call this save as animain. Okay? So, what happens when I run animain is it blows up. Because when I start asking for these classes, it doesn't know what in God's creation I am talking about. Okay? So what if I said import analib? If I did that, then I have to go to from. And I know I was telling you not to do it, and that's all I ever do. Analib import animal, cat, dog. Now if I run it, boom, I'm back in business. Okay? We have compartmentalized our code by taking our classes and creating a class library. So we've compartmentalized it. Classes, like functions, 2 units ago, can be held in libraries. So we created what's called a class library. Okay? And we take it, we load from it, just like we did with our functions. You load your class names, and then you can use classes. At the end of the day, this is when we do object orientation, this is what I want you to see. Because this is what's going to happen when you use third-party libraries going forward in your data science careers. You're going to grab classes, instantiate them, and get objects, and then run code from those objects. That's how things work in the real world, and how to do things, and that's how you're going to get data frames from pandas, and that's how you're going to do other things. That's how it works. Okay? You're going to create objects with your data, and then you're going to call methods on those objects. So this is what I want you to see. I want you to see things work like this. Okay? There is one more thing I'm going to do, because I want you to see it. 1, 2, 3. I'm going to Zotz out this code, but I'm not going to Zotz out the other code. What I'm going to do is I'm going to create a list, and I'm going to call it analyst, which is dopey. I shouldn't have called it that. I'm going to call it analyst, and every time I create an object, I'm going to say analyst.append, and then cat1. Okay? So analyst.append cat1, analyst.append cat2, and analyst.append dog1. All right. Now, what I'm going to do now is print analyst. Okay. And I get the cat object there, the cat object there, and the cat object there. Interesting. I thought it might give me the animal object, but it didn't. It gave me that. Why did it give me that? I thought it was going to print. Maybe it doesn't print. Maybe it just does give you the memory object. Interesting. But it does show me that I do have objects in my list. Interesting. I did not know I was going to get that. I thought that I was going to get my, whatchamacallit, my animal object, my Felix. Interesting. Very interesting. Anyway, watch me work, because this is the whole reason I wanted to do this. For I in analyst, right? Oh my God. Watch this. What do I want to do? I dot speak. So when I run it, meow, meow, woof. Okay? That's polymorphism. That's what happens when we get polymorphism. I filled my list with my objects. Let's say I had 10 or 30 or 100 animals in there. Well, all I have to do is iterate over the list and run the speak method, and my animals are going to sound off for me. So cat 1, meow. Cat 2, meow. Dog 1, woof. That's polymorphism. That's where polymorphism comes into play. Because I've got a list of objects, and they each have do different things based on their context, even though I'm running the same method on them. Okay? I figured while I was here, and I had a bunch of different objects, but they all had the same, polymorphic method that I would do this. I would stick them in a list, and I would iterate over that list, and I would run the speak method. That's polymorphism, all right, to harken back to the last video. But that's what we're talking about with polymorphism. I'm running speak on everything, but I'm getting different results. Because depending on the context or the kind of object I have, speak is going to do different things. All right. This is enough. I'm taking this code and I'm going to put it up on canvas. So you're going to have animain and you're going to have analib. So you'll have the dog, you'll have the cat, you'll have the animal class, and then you'll have this main code. Take it, play around with it, bend it, play with string, play with the different class variables, do different things with it, okay? You can iterate. You can create 20 animals instead of just 3. You can do a whole bunch of things. That's what the whole idea is, okay? This is going to be the last review video, at least the last official one, for Unit 5. So after this, you're going to get your assignment, in a couple of days. And then you'll have all your resources, you'll have your slides, you'll have your 3 review videos, you'll have your Zell readings, and you'll have all the things that you need as far as object orientation and working on the assignments for this particular unit, okay? All right. I know this has been a long one, but this one usually I run off at the mouth and I have fun doing it because it's neat to add all these little things, and it's you have the big lump of clay in front of you and you want to start molding it and making it into good things. So we did the class variable so we could keep count of our different animals, and we did deconstructors so that way when we get rid of objects we can do things as well as the things we do when we create them, and we overrode strings so different things happen when we print, even though it didn't do it when it was in the list, which I found surprising. I'm going to have to hit Google and figure out what was going on there. But that wasn't really the point. The point was to iterate over it and make everybody speak to give you a little idea of what polymorphism is about. The most important thing, though, to my mind, is that we have a cat class and a dog class that inherits from animal. We took them all and we put them in a library and we compartmentalized, okay? So that when we ran our main code, all we had to do was import all that stuff. And then when we imported all that stuff, we could use it in our main program. So we compartmentalized and we kept things modular. All right? All right. Excellent. So I'm going to get out of here. You watch these videos a couple times, soak all this stuff in, and you'll be fine for the assignments. All right? All right. I'm getting out of here. You be good, and I will talk to you very soon.